So now we want to talk about dividing polynomials. We're still actually kind of trying to get at those zeros. So before we would factor to find zeros, now we're trying to find zeros to factor because, we didn't have that many methods. We had grouping. It was possible we'd have a difference of squares where one of them was a polynomial squared. And then we had the quadratics and the cubes, but most things we can't factor right away. So if we can get some of the numbers, some of the factors out, and get down to, say, a quadratic, then we can move on with quadratic formula or traditional factoring of quadratics. But most polynomials you can't just look at and factor. So we're trying to get at the zeros. So we're going to start out with division. So let me say a couple of things. First of all, if you ended up with, when we say factored, let's say we factored something and we got this. This is where we get the zeros from. So if I had had this to begin with, I could have divided by 2x plus 7, say, and I would have been left with this polynomial and no remainder. So this is how division is related to this thing. Let me first start by talking about long division of numbers. So if I write, say, this, then I come over here and the 6 doesn't go into the 4, but the 45, it goes in 7 times, and then I write down this times this, and then I subtract. Okay, so pay attention to the process because you probably do it automatically now. So I've said it goes in 7 times here, write down the 42, get 3 left, and then bring down the 7. And then we say it goes in 6 times 6 times 6, we write down here. Well, you know that's a 6 there. Okay. And the 1 is just left over, so we say remainder 1. This means that 457 could be written as 6 times 76 plus 1. This is going to be relevant to us. The other thing that I want to note about this long division the thing that you probably don't think about all the time when you're writing down numbers is the base 10 factor of them. Factor, I don't want to use that word, but the property, the fact that it's base 10. The reason it's base 10 is because we have 10 fingers, and so did the cavemen and whoever started counting. That's the only reason it's base 10. But 457 is 4 times 10 squared plus 5 times 10 plus 7. Numbers are really all polynomials with a 10 instead of an x. So they behave the same way. So division of polynomials is actually very, very similar to division of numbers, long division of numbers. The only thing is that I would know how this 10 is related to, say, the 6 or the 4 or anything. I know how 10 squared compares with 10. I don't know how x squared compares with x because I don't know what x is. That's the only difference. So sometimes where we subtract in a given way, we can't with the x's and we can with the numbers. So you'll see in a minute what I mean. But otherwise it's the same process. Let me come back over here and get this first one. Okay, so I want to divide that polynomial by that one. Note that if you had been given, say, 405, this would be 4 times 10 squared plus no 10s plus 5. But you have to put that 0 in there as a placeholder that puts 4 in its correct spot. So if you are missing any power of x, you need to put a 0 in it. So if you had no x's, you'd put 0x. So all right, 15x squared minus 41x plus 66, 3x minus 4. Because I don't know how the x's relate to the numbers, I have to just compare the first term and the first term. I can't look at this as a whole and this as a whole like I did with the 45 and the 6. So I just look at the 15x squared and the 3x, and I don't look at anything else right now. 3x goes into 15x squared 5x times. But now when I multiply, I do have to multiply by the 5x by this entire thing. So I multiply 5x times 3x is 15x squared. 5x times negative 4x is negative 20x. And just like long division on numbers, I'm going to subtract now. And that first bit will cancel. Negative 41x minus a negative 20x is negative 21x. So now I just compare these two. It's always just the first term in whatever's dropped down. Negative 21x, 3x goes in negative 7 times. So negative 7 times 3x is negative 21x. And negative 7 times negative 4 is positive 28. Subtracting the whole thing, these two cancel. 66 minus 28 is 38. So I have a remainder 38. I want to go back to that thing that I said before about how that means we can rewrite the product. That means we can rewrite 15x squared minus 41x plus 66 to be equal to 5x minus 7 times 3x minus 4 minus 4 plus 38. That's going to be relevant later also, that we have this plus something on the end. I think that the second question was synthetic division. Yes, so let me show you. If we're looking for zeros, then we're not normally dividing by anything other than x minus whatever the 0 is. So if we're looking to see about 2, to try to factor out 2, we'll check x minus 2. If the remainder is 0, so remember that if I have the polynomial and I factor out x minus whatever, and I get some polynomial, and then remainder 0, that means that p of x equals x minus h times some other polynomial plus 0. So that means this is a factor and h is a 0. So that's what we're really looking for, is to see if the remainder is 0. But then there's a remainder theorem that I'll address in a second. So we're really looking to factor out things that look like x minus something. So I'm going to bring this one over and kind of use it to explain what we're doing. So on a first pass, I'm going to do this. I'm going to say x cubed plus 4x squared plus 2x minus 4 divided by x plus 2, long division wise. So x cubed divided by x is x squared. Multiply this times both, we get x cubed plus 2x squared. These two cancel, 4 minus 2x squared, so we get 2x squared. Bring down the 2x. So 2x squared divided by x is 2x. 2x squared plus 4x. So minus 2x, bring down the minus 4, minus 2 times those. And that leaves us with 0, so the remainder is 0, which means x plus 2 is a factor. So x plus 2 is a factor. So x equal to negative 2 is a 0, because if I set this equal to 0, when I move over the 2, it's subtracted. Okay, so I want to show you this thing that has been shown to us here already, filled out. 1, 4, 2, negative 4, I read off the top there. The top one is the polynomial that you're dividing. The minus 2 is the 0 that you're checking. That's the x that you're checking, so you do x plus 2 if you're going to do long division. But what happens only if it's x minus that number? It does not work if you have an x squared or a 3x or anything else. It has to just be x minus something. Then what happens is, when you divide these, you're always just going to get whatever the number was here. If it was 4x cubed, we would have gotten 4x squared, so the coefficient here would have been 4. If this coefficient was 7, that would be 7, 8, 8, negative 5, negative 5, because we're dividing by x. So the coefficient doesn't change, just the power on x. Then we get this negative 2 times that one, times the 1 right there, and it gets added. So we had a plus 2, and then we subtracted it. So we do 4 minus 2, because that plus 2 gets subtracted, and we get 2. And then again, we're just dividing by x. So we still get the same coefficient, so we get the 2. Now we're multiplying the 2 times the negative 2, because we did 2 times 2, but we subtracted it. So if you look at the numbers after the 1 drops down, so the first one drops down, and then we've got minus 2, and then we've got minus 4, because these are always canceling. And then this is really a plus 4. That's these numbers here, minus 2, minus 4, 4. This is a shorthand way of writing that same thing, and here's how you do it. This is called synthetic division. So I would have been given x cubed plus 4x squared plus 2x minus 4 divided by x plus 2. Or I would have been told see if negative 2 is a 0. I make sure I have every degree covered. I can't have a missing one. If there was no x there, I would write plus 0x. And the first thing to do is just write the coefficients of the polynomial. This notation is not the way I usually do it. I do it like this. I put this block there. And then the x plus 2 tells me a 0 of negative 2, so I wrote negative 2 over there. 1 comes down. Negative 2 times 1, add. Negative 2 times 2, add. Negative 2 times negative 2, and add. The result now is that this has become the constant value. So you started out with cube, squared, x, number. Now we've got squared, x, number, remainder. The fact that this remainder is 0 means it factored out. So this original polynomial is x plus 2 times, and then these are the coefficients of the new guy, x squared plus 2x minus 2. When you started out with this, you would have had no technique to factor it that we've learned so far, but now we have a quadratic, and you could just use the quadratic formula if you wanted to. So going back to the actual question, they've done the synthetic division already for us, so we want to write the polynomials representing the dividend, the divisor, the quotient, and the remainder. Okay, so that is just reading these off. You see there are 4 terms, it means the first one's a cube. If there were 5 terms, the first one will be a fourth. 3 terms, the first one is squared. So it's always just one lower degree than you have numbers there. The divisor is the thing we're taking out. X plus 2, because if x plus 2 is 0, then x equals negative 2. The quotient is this part down here that's left, so x squared this time because I have 3 pieces. And the remainder is 0. The remainder is in this box here. So now we want to use the remainder theorem to evaluate this for, I guess, 4 different values. So start with that one. Actually, I don't want to take up that much space. I'll just remember the 3 there. Seven minus 5 minus 42, 30, and I'm not missing anything. I have cube, squared, x, number, all. I wanted to find the value of h of 3, so I just put 3 over there. If I was trying to factor it out, I'd be factoring out x minus 3, but when it says to evaluate h of 3, I put 3 there. Bring down the 7. 3 times 7 is 21. Add these, 16. 3 times 16 is 48. Add those, 6. 6 times 3 is 18. Add those, 48. This is the remainder. This means, I'll write what this means one time, and then for the rest of this problem, I'll just answer the question. This means 7x cubed minus 5x squared minus 42x plus 30 equals x minus 3 times 7x squared plus 16x plus 6 plus 48. So if I plug in 3, then this is 0, so this all cancels, and I'm left with 48. Oh, I should have kept that. Now we want 5/7. Bring down the 7 times 5/7 is 5. 0 times 5/7 is 0. Negative 42, so I'm just adding every time because we already took care of the negative by the fact that this is x minus 5/7, and we're making it positive. So that's the subtracting part of the division. Negative 42 times 5/7 is negative 6 times 5, negative 30, 0. So right there, that would have given us something to factor out. We could factor out x minus 5/7, and then what's left is a quadratic right here, 7x squared minus 42. Square root of 6. Bring down the 7. 7 root 6. This is very strange. 7 root 6 minus 5. Up here I need to put 7 root 6 minus 5 times root 6. So 7 root 6 times root 6 is 7 times 6 is 42. This is minus 5 root 6. So if I add these up, I get minus 42 plus 42. That cancels, and I'm left with minus 5 root 6. Multiply that times root 6, and I get minus 30. And again, 0. Negative 3. Seven times negative 3 is negative 21. Add those. Times negative 3 is positive 78. Add those. Times negative 3 is negative 108. I'm just skipping 8 every time. So, okay. So this is how we kind of use this technique now. We've beaten it to death. Let's use it. We're given that negative 1 is a 0. So if I take out x plus 1, I'll be left with a quadratic because this is cubed. And I did again make sure I had every power of x there. So I'm going to take out negative 1. 2 times negative 1. 11 times negative 1. Negative 63 times negative 1. So it's x plus 1. 2x squared plus 11x minus 63 from here. Now this probably needs to be factored using the quadratic formula. So I'm going to say if that were to be equal to 0, then x would be negative 11 plus or minus the square root of 11 squared minus 4 times 2 times negative 63 over 2 times 2. Oh, look at that, it would have factored. Keep that just for the moment. So negative 11 plus or minus 25 over 4. Negative 11 minus 25 over 4, or negative 11 plus 25 over 4. So negative 9 and 7 halves. So we know we have an x plus 1, an x plus 9, and an x minus 7 halves running around. But also, this thing had a leading coefficient of 2. So somewhere one of these x's needs to be a 2. So I've got a 2. Basically, the 2 was factored out here. I'd probably want to put that 2 over here to get rid of that 7 halves so that we would have x plus 1, x plus 9, 2x minus 7. But I'm not even actually sure yet what the software wants. So let's see if I put it in this way, if it's fine. I have a feeling it would take it either way. I think these programs are getting better. Oops. Okay, it took that. So solve f of x equal to 0. That's actually where we started. So -1, -9, 7/2. Two more. We want a polynomial that meets these conditions. A degree 2 polynomial with leading coefficient of 1 and zeros of 2 plus 5i and 2 minus 5i. Okay, so here's another thing I need to address very quickly. Let me just, let's say we were trying to factor this one. So we would do equal to 0. X equals -1 plus or minus the square root of 1 squared minus 4 times 1 times 1 over 2 times 1 is -1 plus or minus root -3 over 2. So this is just like before with the 25, except that I don't get to clean them up. So I get -1 plus root -3 over 2, -1 minus root -3 over 2. Because I don't have like terms to combine, I don't get to come up with just a fraction. So I is the square root of -1. So whenever you see a square root of a negative, you just drop the negative and tack an I on the end. So this is -1 plus root 3 I over 2. -1 minus root 3 I over 2. So this one's -1/2 plus or minus root 3 over, that one's plus, root 3 over 2 I. This one's -1 minus, -1/2 minus root 3 over 2 I. The point of this, I wish I didn't have a scribble, one thing I need to bring up here, but because it's always going to work out this way, they're always going to come in pairs. If you have an I, so in this case, if you had -1 plus root 3 over 2i, and you told me that was a 0 of your polynomial, I would know for a fact that -1/2 minus root 3 over 2i is also a factor of your polynomial. Because if you have one, you have to have the other. These are called complex conjugates. So if you were told a plus bi is a 0 of the polynomial, then you know a minus bi is a 0 of the polynomial. In this case, it is telling you actually both of them, but it doesn't have to. It could have just given you one of them, and you would have to put in the other one, because otherwise you end up with i's in your polynomial. And then it's not a polynomial over the reals anymore, so you have to include them both. Okay, so in this case, it's telling you degree 2, that means it needs to have 2 zeros. The leading coefficient is 1, so we don't have to multiply through by anything at the end. And these are 2 zeros, so those are your only 2 zeros. So we have x minus 2 plus 5i and x minus 2 minus 5i. I'm going to leave it like this and FOIL it, even though I'm going to have more foiling later because I've got this binomial here. So I'm going to do FOIL. First 2 x squared. Outside is minus x times 2 minus 5i. Inside, minus x times 2 plus 5i. And then last is plus 2 minus 5i, 2 plus 5i. So x squared minus 2x plus 5ix minus 2x minus 5ix plus 2 minus 5i times 2 plus 5i. When I FOIL it, I'll get the 2 times 2, but then minus 10i plus 10i, those cancel. And then I get minus 5i times plus 5i, so minus 25i squared. X squared, these two cancel. I've got minus 4x plus 4 minus 25i squared. I, remember, was the square root of negative 1, so I squared is negative 1. So plus 4 plus 25. So now you've seen, hopefully, how these i's kind of get rid of each other if you have the complex conjugate. But if you have anything else, it doesn't work. If at this point it had asked for a leading coefficient of 3, you just multiply through the whole thing by 3. Okay, a metal block is formed from a rectangular solid with a rectangular piece cut out. We want to write a polynomial that represents the volume of the block. The first thing to consider, you could kind of split it in weird pieces, but we don't know. Typically you could, but we don't know what this little distance is. Well, I guess we do, so the rest of it's 4x. So you could split it in pieces. You could do this little piece and this piece and this piece kind of separately. But we can also just take the whole block minus the little. The whole block has volume x plus 2 times 4x plus 2 times x. That's just length, width, height. The little one has 4 times 2. Still times x though, because it's all the way through. So it's 8x. So we have x plus 2 times 4x plus 2 times x minus 8x. I'm going to FOIL this, and then I'm going to just, well, I guess I'll do it in 2 steps. So foiling these first two, four x times x is 4x squared, plus 8x plus 2x plus 4. So this is 4x squared, cubed, plus 10x squared, so I'm putting the x through now, plus 4x minus 8x. Now we want to use synthetic division to evaluate if it's 3. So this is the last thing. I have 4, 10, minus 4, 0, because I have cube, squared, single, but I don't have a number, so I need to put that 0 over there. Forgot what we were checking. 3. 4 times 3 is 12. 22 times 3 is 66. 62 times 3 is 186. And that's that.